Hey everyone, we're Group 5 and we're going to talk about some questions from Mod 1 and Mod 2. So let's get started.
The first question is Mod 1, question 4b. The internal auditors of a large company are interested in the system by which incoming voices are processed. They take a random sample of 50 completed invoices and check them in detail for correctness of procedure. 4 are found to be defective in some way. The auditors then suggested some modifications to the procedure and these are implemented, allowing times for the clerk to adjust to the new procedure. The auditors then take a random sample of 60 completed invoices. This time they find 3 incorrect ones. Is there any evidence at 5% level of significance that the new procedure has improved the rate of error? So from the question, N1 have 50 samples, 4 found to be defective. So P1 hat is 4 out of 50 or 0.08. N2 with 60 samples, 3 found to be defective. P hat 2 will be 3 out of 60 or 0.05. Since the question wants to find the new procedure has improved the error rate, we shall conduct a one-tailed test. The level of significance is 5% or 0.05. Alpha will be 0.05. Since N1 and N2 are above 30, we can use the z-test. From the z-table, the critical region is 1.645. For our H0, P1 minus P2 equal to 0, while our H1, P1 minus P2 is greater than 0. So for the test, we are going to test the difference between the two proportions, where z equal to P1 minus P2 over the square root of P hat 1 minus P hat over 1 over N1 plus 1 over N2. First we have to find the total pool of P, where it is shown on the right, N1 times proportion P1 plus N2 over N1 plus N2. So our pool P hat will be 7 out of 110. So when we sub in the formulas, 0.08 minus 0.03, we will get the top, while at the bottom 7 divided by 110 bracket 1 minus 7 110 bracket 1 over 50 plus 1 over 60 bracket. So we multiply to all the numbers together and square root it, we will get the z value of 0.641804554, and we can estimate it to be 0.6418. So from there, since z is 0.6418 and is smaller than the critical region of 1.645, we do not reject H0.
Mod 1, question 4c. So a health spa have invested a weight reduction program. As somewhat as an overweight exercise interest in the program, and then the program can have the peculiar to reduce an average of more than 7 pounds. The spa allow him to set that from the patient. It's a 10 patient, and then the assessment is a population that have any evidence to suggest that program can reduce on average, and then the weight is more than 7 pounds at the 5% of significance. So from this chart we can see all 10 patient of the weight and before and after. So move on to H0 is a mu equal to 17. H1 is a mu larger than 17. The significant level is 0.05. All the data is given by the question. So we use the t-test as a one-tailed test. So critical region from the t-level is 1.833, and then we need to calculate two of the difference before and after. So put all the data together, divided to 10. Finally, we got 19.7. Okay, so we need to calculate the standard deviation. So we use this formula to calculate. So we got the result is a 4.3982, and then we need to test the statistics. So it's put all the data together, and then finally we got 1.94. So since 1.94 is larger than 1.33, so it's H0 is rejected. Then the hypothesis that the somewhat overweight exercise can help the particulars to reduce is not rejected. An interested program is reduced weight at 0.05 level of significance.
I'm going to talk about the question 4b in Mod 2. We need to test the mean of a population. From a question, we can get the information of sample size, which is 64 households. The average monthly income of it is $70,100, and the standard deviation is $1,200. We need to test whether the average family income can be more than $80,000 or not at its 0.01 levels of significance. The first step to do this question is to set the hypothesis, which is HO equal to mu equal to 80,000. H1 is equal to mu larger than 80,000. The significance level is alpha equal to 0.01. And for the alternative hypothesis is large, so we don't need to divide 2 for the 0.01. Therefore, the critical region is set larger than 2.325. And since the sample size is equal to 64, which is larger than 30, so by the central limit theorem, the sampling distribution of mean is approximately normal. In addition, alpha is known. Therefore, a z-test can be used, and from H1 we should use the one-tailed test. By using the formula, we can get the answer of -6, and -6 is smaller than the critical region, which is 2.325. Therefore, HO is not rejected. We can conclude that the hypothesis that mu is equal to 80,000 is not rejected at 0.01 levels of significance.
And I will talk about 4C. And for this questions, it is to test the age of buyers and non-buyers of a particular product. And here are two independent samples. And the question is to test whether there is a difference between the mean age of buyers and non-buyers at 5% level of significance. So when we are looking at the questions, we could know that because it is two independent samples, so we do not apply the pair test. And firstly, because it is to test the difference, so we apply the formula that is mu1 minus mu2 equals to some values, and in this case, the sum values equals to 0. So our null hypothesis should be mu1 equals to mu2, and the alternative hypothesis should be not equal, which also implies that the critical region of this one should be on the two tails. And the second step, we could see that there is no population variance listed above, and also the sample size for H1 is not large than 30. So we need to apply the t-test. And also we could see that The population variance are not mentioned equal above, but the question allows you to make an assumption. Usually for the third one, it is quite troublesome to adjust the degree of freedom, so here we just assume the population variance are equal. In this case, we just apply the second formula. And the third step is to create a critical region. And knowing that our alternative hypothesis, so we put each 2.5 on both tails. And the degree of freedom should be 38, which is larger than 30. So in this case, we just use the z value to approximate the t value when we are creating the critical region. And after looking at the tables, we could find that the t equals to 1.96. So the critical region should be either larger than 1.96 or smaller than minus 1.96. So the last step should be the calculation. After knowing the data, we could have these values being calculated. So we first calculate the sample variance of the bias, which is this value, and the sample variance of the non-bias, which is this value. We all apply the ungrouped variance formula to this, and we could get the value easily. And we can calculate the SP square, and also obtain the value t, which is minus 1.9557. And we could see that it is not in the critical region. So our conclusion is assume the population variance equal. We should not reject H0.
Now let's talk about Mock 2 question 5a. A management training program is organized by a company to teach supervisory skills. The participants attempted the examination before and after the training program, with higher scores representing better supervisory skills. A random sample of 10 supervisors is selected, and their examination scores are shown below. Test whether the management training program is effective in improving supervisory skills at 5% level of significance. State the assumptions. Now, this problem belongs to testing the difference between two means. Let's mark out some keywords in the title so that we can solve this problem more easily. The first one is a random sample of 10 supervisors. This indicates that the size of the sample is 10. Next, the highlighted in red is at 5% level of significance. That means we need to solve this problem with 5% level of significance. Here comes our solution. From the given table, we can generate the following table. We find that a new row named improvement is shown. Note that improvement is equals to post-test minus pre-test. Next, denote improvement as x. As for x, the size of x is 10, the average is 6.9, and the standard deviation is square root of 883 over 30, approximately equals to 5.425. With these statistics, we can generate a normal distribution. Suppose it is satisfied with normal distribution, so we can find this form of normal distribution. The average is 6.9 and the variance is 883 over 300. Next, with these basic steps, we need to do it in the testing hypothesis. This question is aimed at finding whether the management training program is effective in improving supervisory. Therefore, the improvement between two tests should be larger than 0. So first step is formulate the null hypothesis. In this problem, the null hypothesis set H is 0 is mu equal to 0. Next step is formulating the alternative hypothesis. In this problem, our alternative hypothesis H1 should be mu larger than 0. Next, specify the level of significance to be used. From the table, we know that we need to solve this problem at 5% level of significance. Therefore, alpha is equals to 0.05. Next, select the appropriate test statistic and establish the critical region. So from the problem, we find that the degree of freedom is V equals to n minus 1 is 9. And from the table, we can get that with V equal to 9 and alpha equal to 0.05, so that T is equals to 1.833. That means our critical region is T larger than 1.833. Next, we need to compute the value of the test statistic. T is, after the calculation, we find that T is approximately equals to 4.022, which is larger than 1.833. Next, we need to do the decision when reject H0 if the statistic has a value in critical region, otherwise accept H0. Obviously, we can reject H0 because the statistic has a value in critical region. Therefore, the final step is to draw a conclusion based on the step 6. Our conclusion is that the management training program is effective in improving supervisory skills. This is the end of our presentation. Thank you for your watching. If you like our video, please don't hesitate to subscribe us and give us the grade of excellent. Your comments count a lot. Thank you again and wish you have a pleasant day.